Although some of variable is in Chinese, but basically you don't need to worry. You just need to know the idea. As I said, that if you have a chance to do this research, the first choice for you is come to me and ask me how to do this. Okay, but at this time point, I just give you a sense about how to do this. The first, I give you the idea of the data set. Okay, this is the data set I create. Again, because this is a personal data, so don't record, okay? But much more have a real sense, so you just forgot. After this class, you just forgot. This is the first scholar. This is her name, and this is the year. It's 1997. Okay, 1997. In Taiwanese year is 86. This is her academic field. This is the gender. This is the department. This is faculty rank. Okay. This is when she was born. This is the key. So we can calculate in 1997, how old are you? So this is very crucial, right? And see, this is her school, graduate school. It's Purdue University. And this is academic administration position. You can see for over this year, she never get the administration position. And this is the undergraduate class teaching hour. See? This is hours. This is the graduate school. This is how many master advising she coach. This is PhD student advising. This is the number of granted project. Okay? What is cohort group? I a little forgot. Okay? That is the academic year, because here, from here is the teaching hour. Okay? This is the teaching hour. Okay, this is her age. See? Age square, gender. Okay, I understand. Previous is the raw data, then I recall it. Okay, so this is the raw data. You don't need to care about this I here. This is the estimation created by stata. It's not what you can do. So this is a panel data. It's like you have one scholar observed how many years? 20 years. See? From 1997 to 2016. Okay? So this is another scholar. Okay? So answer your question. You just Dongxian just ask her. See this scholar, Professor He, here, assistant professor, 2003, then 2004, he become associate professor.
Oh,
sorry. Okay. Okay, can you see it?
Ask a question.
Please.
If I got a project this year and then I got another project next year, so what's the amount of project next year?
You mean you get the project this year?
Yeah.
And then what?
And then I got another project next year.
Oh, based on the year you get.
Okay.
Based on the year you get. So this is a reason why I choose the Office of Accounting. The money will come, mean you get. Okay, some people, I promise you get the money, but you never get the money, or you delay get the money. Okay, so we follow the money. Okay, so I think for the data structure itself is not difficult, but the problem is how to get the data is most challenging. Okay, So this is a data set. Okay, this is a total data set. Okay, so let me close this one. Okay, how to do the analysis? Let's try. There has a couple of things. It's very important to mention. It's this one. I will make it larger. Okay. Hold on a second. Do you still remember what the eststo is for what? It's for what? For produce the regression table in the words. So let's start from this one. Okay? It's clear to you? Mix is different from regression. Okay? You all know regression, but the regression is for what? Regression is for what? Regression is for just cross-sectional, because regression is not a plain longitudinal data. If you are dealing with the longitudinal data, it would be XT rate, right? But what is mix? Why? If I'm doing the longitudinal data, why I did not choose XT rate? Is this one? Why? Because I use the life trajectory, the mix model. What is mix? There has a tricky here, but I will not explain to you too much detail. But basically, if you want to observe what, okay, because mix is your research productivity has highly association with the previous year. The next time, the previous time, when you see the mix is also used for HLM. Hierarchical linear model. It means you have student here, right? And you have level belong to the one school, right? In this case, it's hierarchical linear model, which means you should use the mix. Okay? But you should ask me, why? I always tell you that this is a longitudinal model. You should use the XT rate. Why? In my case, I still use the hierarchical linear model. How come? Do you have any idea?
Because the sample is in one.
You are right. Year 1, year 2, year 3 from the same faculty. Why I know it? Read the paper. They tell you this should go to the mixed model, not the longitudinal. What happened with the longitudinal model? These two statistics, I will not give you too much detail, but if you want to do this one, come to ask me. I will refer you to the paper. And the interesting thing that the paper that I'm working with Nico, we are doing the mix. We do what? Double mix. Nested classified. Okay, but never mind. Next time we tell you. It's not this year is all nested by the same faculty, right? So each faculty they have their multiple year. Okay, so this is the model that we choose. Okay, are you good? But don't remember. No need to remember. If you encounter the modeling modeling choice, just come to me. Okay? Because I tried before. That I try to explain to you guys, and then you will forget. Then I give up. Okay. Then after mix, basically is doing the regression, but consider this kind of data structure. Then we put the Y. See here, the number of granted project. Then it's our most interesting which is age. But what you think I missed something, right? What I miss? What you should think, but you did not find in this equation, Steve? This one. Age 2 is square term. Okay? Then I dot gender, control the gender. Here, I dot faculty ranking. This is what you just asked. Okay? And the I dot STEM, academic field, and the I dot whether you have administration position or not. And the control the teaching hours in undergraduate and the graduate school, and the number of the master advising and the PhD advising. So those are basic things. But the most challenging thing is here, center year. I centralized. Okay, I just add here. What is this? If you want to do the mix, you need to tell them the second level is what? It's faculty. So you see faculty ID is here. Okay? And then control lots of things, those details. I would refer you to read a handbook of stata to tell you how to build this modeling. But basically, they just tell you in what kind of situation you should write your equation in this way. So, but based on this example, I just want to remind you, when you want to do the statistic, don't think it is a simple test. No, it's much more complicated than you thought. You need to consider all the conditions you need to consider, including, as I tell you, time series. You need to control the residuals. But those is about statistics. We don't want to talk here, okay? So basically, you just run. Let me try. Okay? This is the result. See? Age. Significant, right? And I think the age square is on the bottom. Yeah? Okay? Okay, just by running this code, you can get the table as Steve present the age. What else? What else we want to talk? Let me open the paper, okay? That's much easier for you to imagine that. Okay, then I want to introduce how to produce this graph. Okay, this graph you cannot just do it descriptive. It is based on the calculation. So how can we do this? There has a code called let me see, unconditional. Okay, this one. TS smooth. Okay, let's try. because it's a little bit. If you want to, okay, the first thing, if you want to produce this graph, okay, you need to run the equation first, okay? You need to run the mixed effect first, then they will save the coefficient in your data. Then you make a graph by using those saved coefficient. If you did not run this one first, it's no way for you to produce the graph. So let's do it. I have a group 1, group 2, right? So let's try the group 1 first. Because I want to put the two lines together, okay? So I need to run the group 1 first. Group 1 just keep the early success, those early promises. Okay? This is, you get. Can you see it? Only for the one group, the early promising. How you get this white head is based on here. Don't worry, I will do it again. I just give you the idea, okay? Then I save this data. Oh, I already saved, so I don't want to do it. Then let's create the group number 2. See, I just keep the early success equal to 0, not the early success. So let's run it. Okay, I have a result, right? But don't forget to do this one. Predict whitehead group. If you predict, you have additional variable here. Additional is created because you run the equation. Because you run this equation, then you will get this one. Then keep. You see? The edge and the effect. The edge and the effect. Then merge these two files together. Edge. This is for group 2. This is for group 1. And until 55. Then create. TS smooth. TS smooth is hot. It's to do the smooth. In mathematics, they have a technique to do the smooth. Because if you did not do the smooth, they would, yeah, it's not beautiful. So it is okay to do the smooth. Okay, when you do the smooth, then you are ready to produce your graph. Okay, let's try. If you did not do the smooth, see, NLE1 is smooth after the smooth, right? If I did not do the smooth, I pick the raw data, okay? I pick the raw data, group 2. Okay, so it is okay to do the smooth. So when you read my paper, I say what? So you found that I do my social science seriously. I have my own reason to do it. And what I did, I will always put a note. But I will not be the first one to do it because I found economic people, they do this. Because it is reasonable. Because sometimes they will jump. You just want to find a trend. Okay? So let me do it again. Okay? So now you will have a better idea. So we just compare early promise and not early promise. Now I want to compare gender. So we still use the same data set. Okay? But this time, we keep the gender equal to 1, which should be the male, right? So you will see those observations delete because we just want to count the male professor. Okay, then what? Then we run this model. We run this model. They give us a regression table, but the most important thing is like we want to produce the graph. So we ask the stata to give us the predicted value. See, they all are the male, okay? So I will not go through. So this is their predicted value. See, this is 1.20, and this is the age. This is their age. Age is age. Where is age? Age is here. All the people in this age, they will get the same value. Okay?